Good morning or good afternoon. How are we doing? We ready to go?
Yep. Thanks, Hailey. Hello, everyone. Good morning, good afternoon, good evening, wherever you are joining us from. And thanks for joining. My name is Shruti Pathak. I am a product manager for Azure Cache for Redis, and I will be your host for today. So this is our first stand up, and I would want to I would just want to start by saying welcome everyone to our first community stand up for Azure Cache for Redis. We are so happy to have this opportunity to share the latest new releases, features, demos with you all, and most importantly, engage with all of you in a live forum. Like whether you are, if you're looking at the recording or anything, feel free to reach out to us at AzureCache-PM at Microsoft.com. And we intend to do this community stand up fourth Tuesday of every month. So if you have suggestions or topics that you want us to cover for our upcoming community stand-ups, please feel free to reach out to us or drop a note, and we'd be happy to engage and happy to listen to you. Since this is our first stand-up, I want to take this opportunity to do some introduction of what is Redis, how does it help your applications, and where can you use it. So those of you who don't know, I'm sure most of you probably know, but those of you who don't know, that Redis is actually an open source in-memory key value data store, which supports very simple commands like set key value and then a get key value, right? This is simple. Like, how is this exciting? Why is this exciting? Because it's an in-memory store, it can provide sub-millisecond latencies and can scale to about millions of commands per second. And the design is a very simple, straightforward key value pair design, which is perfect for caching and storing ephemeral data. Because of all of these characteristics, Redis is very versatile, and you can use it as an accelerator for your application, where you can cache the output of your APIs or your database queries, and that will help you make your application more performant. You can also use it as a distributed cache or a data store for your ephemeral data like sessions and tokens and passwords. And then you could also use it to share state across stateless services. If you're hosting, say, tens of pods on Kubernetes and you want them to share state, how do you do that? You could use Azure Cache for Redis as your distributed cache or a distributed data store for sharing state. And then Redis also offers pub/sub functionality, so it's a great alternative for your messaging or your stream processing. Um, now that you know what's open source Redis, we'll look into the Azure Cache for Redis offerings. So there's an open source based offering, which the tiers are basic, standard, and premium. And then we also have a partnership with Redis Incorporated and offer the enterprise and the enterprise flash tiers, which also offer the more advanced features like the Redis modules and active geo-replication, and they also come with a higher availability SLA. Let's take a peek at what have been the new things that we have rolled out recently for Azure Cache for Redis Enterprise first. So the first thing that I want to talk about is the scale up and scale out functionality. We previewed this a couple months ago, and with this new functionality, you can now scale your cache up, make it a bigger cache, and scale out, and make it scale with your application. And all of this happens in place without any downtime or data loss. So that's great for scaling your applications, and your cache just scales with it. The second is the Redis JSON support. Redis JSON is the module which helps users, Redis cache users, work with JSON data directly as in the key value pairs instead of translating into a string all the time. So you can directly work with your JSON data, and then now you can also work with JSON data on geo-replicated caches. So that was also previewed. The next thing is the flush operation on the active geo-replicated caches. So these caches, the active geo-replication, does not support the flush DB and the flush commands that the Redis supports. So instead, we have provided a new management or a control plane level operation that will let you flush all these caches together. And then we also rolled out support for your bring your own key or the customer managed key for encrypting disks whenever Redis stores any data on the disk, you can encrypt it with your own key. And another security feature that we launched was the connection audit log. So you can have audit logs for all the connections, the disconnections, and authentication events that happen on your cache. So you can have all of these in your audit logs and ensure the security of your caches. So that's the enterprise world. Moving on to the OSS-based tiers, what's new in those? So first, I want to talk about the web app plus Redis deployment template. So this is a deployment template that you can use for infrastructure as your code in your applications, and it will help you create a web app, a database, and power it with an Azure Cache for Redis in your architecture. All of these integrations are powered by Service Connector. I'll show you how this looks like on the portal in just a minute after I cover the next slide, but I'll definitely show this on the portal. And what else is new on the Azure Cache for Redis? So it's the new latency metric that we rolled out, the 99% latency metric, which can give you latency of the commands on the server side. So there's already a metric for end-to-end, client to server to back to client, the end-to-end latency, but this is a new metric for just the server side latency of your commands. And we also increased the number of shards that we support for clustered caches. Up until now, it was just 10 shards, and now we support up to 30 shards. That means you can have bigger and more scalable and more throughput for your caches. Again, this is very useful for scaling your caches as your applications grow, as your throughput demand grows. You can now scale and have bigger caches to support your applications. We also rolled out Redis triggers for Azure Functions. This is something very exciting that we all are excited about, as it opens up a whole new set of scenarios that users would want to do with Redis cache and databases. We'll cover the functions and the Redis triggers more in one of our upcoming community stand-ups, but we're super excited about this new feature as well. And then last but not the least, we also rolled out support for Azure Active Directory-based authentication and RBAC. So I know everyone's excited for the demo, so let me move on for the demo for that. So quickly, I wanted to show the template that we talked about. So this is the template for creating a web app and a database. So this is, you provide details for your web app. You can choose what stack do you want, and then you choose a database engine. And along the same time, you are also able to attach an Azure Cache for Redis with your database. So once you specify everything that you need, you can create these resources all together. And Service Connector will take care of injecting the right environment variables in your web app so that it can connect to the database and Azure Cache for Redis. So that's the template. Moving on to the Azure AD-based authentication, I have a quick sample that I created. So this is just a simple leaderboard that's created in Python and hosted on an AKS cluster. Obviously, it's connected with a Redis cache and then also a database. So you can load the scores from the cache or from the database. So let's try doing some things on the score so that we can, verify that the cache is actually really connected to the application. So I'm going to try and change the score for this team. So we're going to use the console for that purpose. We have a console on the portal that lets you quickly run some Redis commands from the portal directly. And I'm using the keys command here just to show what are the keys here. Just a disclaimer, the keys command can be very disruptive in your production scenarios. So avoid or just never use keys command in production scenarios, but this is just a demo. So I'm going to go ahead and just use that key anyway. So I'm going to change the score for one of the teams here and see if it reflects in our application. Let's say the Northwind traders score 100 on 100, and then we go check the application and then refresh the scores. And yes, so the Northwind traders are now at perfect 100 score. So this application is actually connected to the Azure Cache for Redis. Now that we've demonstrated that it works, I want us to take a look under the hood and see how the connection actually looks like from the application side. So the open source Redis offers no access keys or no password based connection methods, but Azure Cache for Redis blocks those, obviously, for security reasons. Every cache that you provision with Azure Cache for Redis is always protected with an access key, and there's just no way to access it without any passwords. So the easiest way to do would be, so when you're connecting, you provide your Redis host name, and then you provide an access key. So you could just hard code and it works. But obviously, there's security guidelines and recommendations that access keys should not live in the code. And then so the next step that you would try is probably put the access key in your key vault. So this is what it would look like when you put it in the key vault. And this works great. You have your host name in your connection string, you have access key from the key vault, and this just works great for most of the users. But obviously, for some bigger enterprises and the other users, just having an access key in Key Vault is not enough. You also want to rotate it periodically. So to help with the rotation, Azure Cache for Redis supports two access keys. There's a primary access key and a secondary access key. So the idea is whenever you are ready to rotate your access keys, you change your applications to connect using the secondary key, and then at that point, when all the applications are connected using the secondary key, you can easily change the primary key or rotate it because no other application is using it. So this is the experience that we have right now. But if it's just one single application or single pod, that's manageable, right? You can do it once in 3 months, once in 6 months, not that bad. But imagine if you have tens or hundreds of pods connecting to the same Azure Cache for Redis, and then you also have a web app sitting in app service, and you also have a functions, which is also connecting to the same Azure Cache for Redis. And now quickly the problem escalates, and now you are expected to coordinate across all these applications in various platforms and then coordinate the key rotation. So that quickly becomes a nightmare for the users. And we acknowledge that, and we know it's a big problem. And here's what the solution is. Here's what we have the solution for you is to use managed identity. So you can now create Azure Cache for Redis and then connect to your Azure Cache for Redis instance using a managed identity. So this is how it would look like from your application side. So you have your managed identity. You fetch you fetch a managed identity token for your Redis cache scope, and then look at how the connection string looks like now. So you have the Redis host name as before, and now instead of the access key, you are using the username as your managed identity object, and then the password is just the token, the access token that you have just fetched from AAD. So you don't need to maintain access keys anymore. Every time you want to connect to your Azure Cache for Redis, just fetch a new access token and you're good to go. You can connect to your Azure Cache for Redis. You can also do the similar thing, similar connection logic with Service Principal. So here's an example with Service Principal. You do the exact same connection logic. You use the Redis host name, and then your username is your Service Principal's object ID. So this is just an example. We have actually streamlined it further for .NET users. We now have a Stack Exchange.Redis extension, which will abstract out a lot of these things of how to get the token, how to refresh the token periodically. All those token lifecycle management operations will be taken care by the extension, and all you need to do is just provide which managed identity do you want to use to your Azure Cache for Redis. So do check out that's the extension that we have in Stack Exchange.Redis. We've also recently published code samples for other non.NET client libraries. We have Java samples, Python samples, and also Node.js samples. So that's the client side of the configuration, but we also need to do some server-side configurations before alongside your client-side applications, client-side changes. So let's take a quick look at what changes are required on the server side. So this was the same cache that we were using earlier. Let's look into it, and we have this new blade, which is where all the magic happens. As you can see there, we've introduced these new concepts of Redis users and access policies. So access policies are based on the open source Redis concepts of access control list. So when you create access policies, you will see these three access policies as built-in access policies. So owner, contributor, and reader. And of course, you can create your own custom access policy. So all the access policies expect permissions in the form of permission strings. And to create the permission strings, you need to specify permissions in three different areas. So first is the command categories. So Redis has open source Redis has actually grouped useful commands together and called them as Redis categories. So you can allow or disallow a specific command category. And then alongside the categories, you can also allow or disallow specific commands. And then you can also allow or disallow specific patterns of keys or key spaces. You can say my service for this user, I want it to restrict access to just this set of keys. No one else can access this set of keys, or only I have access to this set of keys. So you can specify all those command permissions, and this becomes very useful and very handy for data isolation, especially in cases where you have multiple services talking to the same Azure Cache for Redis or sharing the same Azure Cache for Redis instance. This keys command comes very handy for isolating the data that resides in the Azure Cache for Redis. So once you have specified command permissions for on these three categories, you can assign them to a Redis user. Actually, let's try and create an access policy. For example, I am creating a new user scenario for which needs me to create just pub sub only commands. So I'll create a new access policy. I'll call it pub sub only, and the permissions that I want to give it is I want to allow the command category for PubSub. So any user or any Redis user that has this access policy can only perform PubSub commands on your Redis cache. So I create this new access policy, and now I want to assign it to some managed identity or the service principal that wants to use these PubSub policies. So I'm going to create new Redis user, and I want the new Redis user or the new service to perform only pubsub commands. So I select pubsub only, and then moving on, I have managed identities for the new services that I want that I'm creating. So I have user managed identities. For example, I have this foo publisher service and the bar consumer service. So these are my new services that I'm creating. There's a publisher service, there's a consumer service, and they can perform only pub/sub commands. So this is the review section. So you are reviewing that I want to perform only pub/sub and for these two managed identities. And then I click assign. So this is how you assign access policies to your Redis users. Now that you've assigned, it'll take a second to load up. It's still running. But I also want to demonstrate how these permissions work. For example, let's go back to our old sample of the leaderboard and try to do something, demonstrate how these permissions work. So if you look at it, there's two Redis users that I have. There's a service principal Redis user and a managed identity. It's a user managed identity and then both of them have different access policies. One of them has the contributor access policy, and the other one has an owner access policy. And if we look at the difference in the permissions, the owner access policy lets you perform all operations on like basically any operation you can perform on that Redis supports, you can perform on it. And then you're also scoping it to all keys. So you have access to all keys as well. But then if you look at the contributor, it lets you do all commands minus, so you're disallowing the dangerous commands. And if you look at the Redis command categories, dangerous commands are essentially commands like flush all keys. This is the keys command that we talked about. It's very expensive to run keys command. And then so you can block some dangerous commands. So currently my application is connected using the service principal. So my application talks to Azure Cache for Redis using the contributor role, meaning it is not allowed to perform any dangerous commands right now. So let's see what happens if I try to do a dangerous command. So I'm going to do a reset scores operation, which is internally going to call a flush operation, which is restricted right now. So if I click reset, it will try to do a flush db command internally. And based on how I have configured the access to the cache right now, the user that I'm using is not allowed to perform this flush db command. So you will see no perm exceptions from your application if your application tries to perform an operation that it is not allowed to do. So let's change it to managed identity. I don't want to use service principal. Let's see how this changes when I change to managed identity, and I save it and I restart my service, restart my deployment. My deployment's changed. I'm going to refresh it. And now it's refreshed, and at this point, the application is connected to the cache using the managed identity, and it should be able to perform the reset scores now. So voila. So now the scores are cleaned out. My user was able to perform the flush command because it's now connected using the managed identity at this point. So I hope this demonstration was useful and everyone is able to leverage this and make your applications more secure and more streamlined using the Azure AD authentication and RBAC. So please do let us know if you have any comments or any suggestions or on that feedback on that on the feature or any of the features. This was the end of our content, but I want to take some time to thank all of you, whether you're joining the live session or watching a recording. Thank you for joining, and do join us for our next community stand up next month. So we will meet you every fourth Tuesday at 10 a.m. Pacific time, and feel free to reach out to us as well at this email address with any suggestions, feedback, questions, anything you have. We are very eager to hear from you all. Thank you. Let's see if we have any questions. Hello.
We had one question so far, and it had been answered in the chat already.
Oh, cool.
And so, this is the question here. And it was for everyone watching afterwards.
Yep. Thank you. Thanks, Hailey. So yes, we have it on our roadmap, and we don't have it right now, but it is coming soon. So yes, stay tuned.
Yes. Well, awesome. Thank you so much. This was absolutely incredible.
Thank you all. Look forward to seeing you all again for next month. We're already super excited and thrilled about the content that we have for next month. We'll talk about Azure functions, how you can trigger Azure functions with your Redis key space notifications, and what scenarios will that open up for you. Yes, please do join us, and we're super excited. Have a great rest of your day and rest of your month.
Bye.
Thank you.